How's everybody doing? Good? I know it's almost lunchtime, and it's hard to compete with food, but I'll do my best, okay? My name is Kilian Ciuffolo. As you can tell by my accent, I'm not from around here. I'm from Italy. And I've been a software developer for more than 10 years. I mostly do JavaScript, which is obviously one of the most rational language ever written, as you can tell by that snippet right there. And yes, on occasion I love to troll people.
Hi everyone, I'm Luca Orio, and I'm a product designer. I'm from Italy too. And with Kilian, we run Lukibear, which is a dev shop based in San Francisco.
So the thing that I wanted to talk to you about today is how utilizing UNIX pipes, a browser, and a little bit of Node.js, we can efficiently monitor our apps in real time. So this is what it looks like when I ran my Node app locally. On my terminal, I just use debug, and then I see the output of the application through the standard output to my terminal session. When I move my application to the server, it's probably going to run through a daemon. It's going to be a daemon, and it's going to log to a file, probably. So in order to achieve the same result, I need to SSH to the machine and remote tailing the file. So assuming that it's well, actually, not assuming this is a real case, I probably have a database, and I need to monitor that as well, because I want to make sure that everything is working as expected. My app is growing, and at some point, I add a worker. There's a web app, so there's an Nginx, serving static files. At this point, to have everything under control, I have 4 SSH sessions. I mean, you can use the session, but it's still going to be 4 windows or 4 panes, 4 panels, depending on what you're using. And it's even worse if you start using microservices, and we're actually encouraging modularity. You should split up your application in tiny ones. And at some point, it doesn't scale. Eventually, it won't scale. There's too many windows, too many logs. You need a way to aggregate them. Also, this is based on the assumption that I have access to the server. Maybe DevOps didn't give me access to SSH, or maybe the way my application is deployed, I'm not even going to have one server to SSH to. Turns out, real-time monitoring is not as easy as it's supposed to be. And usually I have 3 environments. I have development, staging, and production. And for each one of them, I have a stack of applications and multiple components, databases, static files. And each one of those has a log stream that should be accessible to me somehow. And I show you that sometimes it's hard. So what if I could have a web app where I can see all my logs? It didn't require me to change not even one line of source code in my application, and it was really fast to configure. All the tools that I found online, they were failing me. They were failing my expectation, at least of one of those concepts. And most importantly, they looked really ugly. So this is where Artail comes in. This is why I wrote my own. And Artail is just a tiny Node module. It's available on NPM. Therefore, it's a one-liner install. So we got the installation process out of the way. And it comes with 2 binaries. The first one is the server, and then we got the client. And to start piping output to the browser is as easy as piping something into the Artail client. So you spin up the server, Artail server. You echo hello world, or you output something to the terminal, and you pipe it into Artail. And here, we're using web version stable. We're just pulling updates for the web app magically from GitHub stable branch. So this is a win for me, because I started it with 4 windows, and now I have just 1 app running in the browser. And Unix pipes, right? So when I started to use this, it felt great. First of all, because Unix pipes are great, and I feel like I was hacking, piping stuff in the terminal. I felt really cool. And then I realized, well, actually not the first Italian dude being successful with pipes, so kudos to Mario. So let's dig into some of the I/O redirection and pipes you can do in the terminal. So the first line, it's pretty common. You have a long-running process, node process. First you merge std error and then std out. You make sure that you grab everything that's coming up from the app, and you pipe that into RTL, and you create a named stream called API server. The second example is just a comment. It's not a long-running app. It's just a comment that does something and will output something. We grab that, we pipe it to RTL, and also since RTL is a pass-through, it will be saved to a file called mycommand.log. Now, the first example, it's OK. The problem that it's a pipe, so if something breaks along that pipe, it will bring down the server. So if RTL goes down, my server goes down. If the server goes down, the logging goes down. So if we save the log to a file and we actually tail that file, it will be more robust, because when my Node app goes down, I actually see that in the logs, and I will see that coming up again. So in this case, we're using tile-f. If you use the capital F, it's also log rotate safe, because it sticks to the path of the file. And you can also really use it for whatever you want, because it's it's Unix redirection. So whatever will output something to the terminal can be piped to the browser. So pipe all the things. Here the keywords is pipes. And if you look at what it means to use pipes in Node.js, it's pretty much the same thing. We're grabbing process stdin, which is a node stream. We pipe it through a pass-through. We generate 1 object for each line. Then we grab that line. We create a message. We make it a binary version of that message, and we'll send it through the socket. This is actually an oversimplified version of the RTL client source code. The real one, it's not very far from this, but you can check it out on GitHub. Demo time? OK. So I pre-baked a Docker image containing the RTL website, and now I'm just going to run it. OK. So if this worked, now reaching my Docker host, we show up the website. And it's working. This is the website. And I see the log. Actually, I don't see all the log because it's probably using caching. But if I refresh, I see a bunch of requests that my browser is making. Now let's do something more interesting, because I want to see this in the browser, right? So let's pipe this to a file. And now if we tail the file, we pretty much have we achieve the same result now. But the assumption is that you're going to have multiple websites, so this is not viable. At some point, it breaks. It doesn't scale. So what I'm going to do, I'm going to pipe this to RTL into a named stream called website.log. It's a pass-through, so you're still going to see the logs in your terminal. Now, the cool thing is that since it's using UDP, the RTL server is not up yet. And it doesn't break, because it doesn't require a strict handshake. So what I'm going to do now, I'm going to start a new RTL server. Here I'm just enabling debug in my namespace. And we see the app. It's empty. Now, if I refresh this, whoop, a new stream comes in, and it's a log. If I refresh, I see the login coming in. So it worked. Now, since it's started input, what I can do, I'm actually gonna start this with the mute. So if I start just typing into RTL, it will just show up in the browser. Pretty straightforward. One other thing that you can do digging into the awesome and the useless. I don't know why you would do this, but I thought it was cool, and you won't do this, but if you do, I'm with you. I respect you. So you can actually catch something more useful than this, of course. It actually understands data structures. And the cool part about this is that it will understand that it's a data structure and you get syntax highlighting for free. And it also supports JSON 5 also other than JSON, so it's not really strict about the quotes on the key of the object. So that's it for the demo. I'll get back to the presentation. So how does it work under the hood? Pretty straightforward. On the left, you have your stack with multiple applications. For each one of them, you have an RTL client, and they talk through UDP through the server. The RTL server does its magic and broadcasts everything through the browser using Socket.io and WebSockets. And the best part of this, at least in my opinion, because I really care, is that the UI is pretty. And with this.
Thanks a lot, Kilian. I'm glad you like the UI so far. So I'm a product designer, and this is a developer conference. You are probably already wondering, what am I doing here? So why I'm here is because you are the user base, and you can really help us in improving the product. RTL user experience is not a bunch of wireframes. Its user experience starts from the very beginning when you install it from the command line, because it's about simplicity and speed. We were aiming to build a tool that differs from the solutions already available on the market, and we were trying to build something that was fast to set up, easy to use, and that is working with the tools that you are already using in your workflow. Most importantly, we were searching for a tool that doesn't require to open a new window every time you need to monitor a new stream. This was RTL 1 year ago. The tool was already working. We just needed a better UI and some additional features to make it work better. When you have so many streams, you also need a way to access them. And that's why we implemented a sidebar. From there, you can scroll through a list and select them, or you can also search them by using the search feature. Later on, if you want an even quicker access, you can favorite them to pin them at the top of the sidebar itself. Another way to access a single stream is to use the deep linking feature, and this is not just super fast, but is also a good way to share the stream with a collaborator. This is invisible design, and with invisible, I'm referring to something that was intended and studied to be there, but that didn't require any additional design at all. So after using the tool for a little bit, we noticed that it was impossible to have a look at the history of the logs because the viewport was automatically scrolling at every new line injected. That's why we decided to block the automatic scrolling after every scroll event triggered by a user. And then to get back to the original behavior, you can just press the resume button on the bottom right. If you want to focus on some particular kind of logs, you can also filter them with a string or a regular expression. And to make the viewport even cleaner, you can completely collapse the timestamp column. Last but not least, there is setting panels. And from there, you can customize the UI based on your personal preferences. We wanted to implement that because it's really important to give you the maximum control over the tool and the UI. Our tail was designed by following a lean approach. And with lean, I mean that every week we were releasing a little piece of the product, and by adding new features or fixing the old ones, by following feedbacks received from a small group of developers. Now we are in the process of tying the tool to Mixpanel in order to shape the product based on the metrics analysis received from a larger, bigger user base. I hope you like the tool, and you're going to check it out. Thanks a lot.
Thanks. So what's next? As Luca said, we're going to just start to tie up Mixpanel to the tool, so we have more metrics to analyze and use to build new features. It's an open source project. You're more than welcome to help. Actually, we need more help on this. It's not going to be a two-man show. It's not going to try to fix my workflow. And it aims to help everyone. From day one, we started to receive feature requests. We're still talking to the people that ask those questions and request those features. So please jump in. Day one, they asked, well, can I store my logs? Well, not yet. We don't know yet how to do that right. So we're still talking about how to do it right. So please jump in if you know how to do that. The web app is public right now, so there is no authorization layer. That's bad, right? Mixpanel. And this is actually something that I want to work on. I should be able to just spin up a new Docker image and sharing the socket. They should be able to see all the containers running. And it's going to be, I'm going to have all the logs on the web app, just pushing a new container. Also, if you care about security, right now SSL is not supported using UDP. So please +1 that issue. And that was it. Thanks, guys. If you have any questions, I'll be happy to answer them. Please.
I noticed some coloring in your logs. Are you respecting escape codes and things like that, and actually outputting the terminal escape codes? Yeah.
OK, so the question is, are you using ANSI colors? Are you respecting ANSI colors on your log? The answer is yes. It's not perfect because it turns out it's really hard, and it's different. It's not standardized. I mean, it is, but it's different implementations. So we are, yes. I'm trying to do my best to make it one-to-one to what you look at your terminal. So if you have pretty colors in your terminal, it's gonna be as pretty as in the browser.
You say real time, but if there's no client connected, is there any buffering? So like if I were to go on and see, is it going to start at the point where the client connects, or if there's no client connection, is it just piping through as a log?
So the question is it really real time, or is it buffering? What happens if the server is not listening? Did I got that right?
There's no client connected.
There's no client connected. OK. So first of all, it is real time. It's a pipe. So as soon as data comes in, it will show up in the browser. Well, there is some computation delay, but it's really minimum. Again, the client source code, that's pretty close to the real source code that you see on GitHub. If there's no client connected, data is still going to flow through, but since it's a publish subscribe, nobody's going to be there to listen, and it's just going to pass through, and it's going to, well, if there's nobody, nobody's going to be able to see the data, but it's going to keep flowing through the server. It's a publish subscribe, so the WebSocket is closed unless you select the stream in the UI. In that case, you send a message, you subscribe to a new stream, and you start receiving just the messages that you want. Any more questions? Please.
Do you notice any browser limitations? You kind of say like everyone has to be in, like you can handle the browser crashing?
Yes. Yes. So the question is there any browser limitation that's blocking us right now? Yes. Day one, we released the tool. They asked, how can I have a bigger backlog? Right now, the browser can only contain 100 lines. So if you pipe something that's 101 line, you won't be able to see all those 101 line together in the browser. Even if you scroll up, the first one will go away because the buffer it's fixed to 100. We did that because at some point the browser started to blow up. So this is going to fix it. So this is something that we want to implement. So we can actually, the issue is not keeping in memory in the browser the actual lines. The problem is the DOM. Well, what a news, right? But you know, we should be able to get around that if we fix the infinite scrolling. And once we do that, it's going to be a breeze because you can scroll up back in history. I mean, you know, it's just about pretty normal stuff. Just API, you keep scrolling back. Yeah. Yeah, you should jump in the conversation then. Any more questions?
Could I write my own client and use the RTL? My client, I mean like the web client. Is there a way to just connect up to the RTL server, put my own web page set, and pull the data easily?
Absolutely.
But still use the RTL command line as a way to sort of get it into the server and sort of gain the benefits of.
Absolutely. So I actually I asked the same question to myself as soon as I did this because sometimes I don't want to use someone else's web app. Also, the problem with all the other tools that were doing the same thing is the web app kind of died after a while. So the underlying layer was cool, but the web app wasn't maintained anymore. The browser changes more often. So you can totally do that. Web version stable, when we launched the server, it's too far away, and I'm never going to find that slide. But there's a way to tag a particular version of RTL. If you use an S3 tag or an absolute URL, it will actually pull your application, and it will be a web app, and will be served by RTL server. So you have the CLI, and you can pull your application as long as the application knows how to interact with the WebSocket, which is Socket.io, so it's pretty straightforward. You know, it's not something that we wrote, it's a external library. So yes, you can. Any more questions?
Do you consider event source
Can you repeat, please? What's event source? No. So the big issues there is that I didn't want it to break if you change the browser or if you use an old browser, but we should probably do that because it's a tool. This is going to be used by people like us, and we're probably always using the latest thing that came out. So we can probably optimize there. Also, we're using Socket.io. I could have been just using the straight WebSocket. Instead of using Socket.io just because it's easier, there's an API, the publish subscribe. I didn't want to reinvent the wheel, but potentially we could. Any more questions? Okay. So thank you, guys.
Thanks a lot.
You can find it online if you want.